Question number 7b. Examine uniform continuity of cos 1 by x on open 0, 2. Okay. So we need to prove that cos 1 by x, like, is it uniform continuous on 0, 2 or not? Okay. So actually we're gonna solve this problem in two different ways. So for the first approach, we're gonna use a theorem which is if is uniform continuous on an interval, let's say it's d, and if for every two pairs of sequence un and vn in D. So with we're taking two sequences in D such that un and vn, mod of un and vn, so it's actually tends to 0. That means limit un vn is equal to 0. But for this, if we get limit n tends to infinity f of un minus f of vn is equal to 0. So like mod of un minus vn tends to 0 implies mod of functional value of un minus functional value of vn tends to 0. So this is the first approach. So this is actually not uniform continuous on this region. So we're gonna show that we will take two sequence in 0, 2 such that limit un minus vn will be 0, but limit mod of f of un minus f of vn will not be 0. Let's take two sequence. Let's take xn is 1 by 2n plus 1 by pi, okay, and yn which is 1 by 2n plus 2 pi, okay. So now, and they both belongs to, okay, so both of the sequence belongs to a 0, 2. This is xn and yn. These sequences are from this interval. Now this will be 1 by 2n plus 1 pi minus 1 by 2n plus 2 pi. Okay. Now we get that pi 2n plus 2 minus 2n minus 1 by 2n plus 1 2n plus 2. So this will be one. So this will be 1 by pi 1 by 2 of this. Okay. So now um, so now we get that. So now what do we get? Mod of xn minus yn is equals to this one. So now limit n tends to infinity, this will be this will be infinity into the both, like it will be 1 by infinity and it will be 0. So this will be 0. So we get this one. Now we will try to find value of this. Okay, so this will be cos of we have taken that xn is equal to 1 by 2n plus 1 pi, and sequence yn is equals to I actually forgot to mention that, like this n, like 2n plus 1 and 2n plus 2 here, where n belongs to n set of natural numbers. Okay, this is very important. I actually forgot to mention this before. Now what do we get? Fx is actually cos 1 by x. So f of xn, this will be 1 by this, which will be cos 2n plus 1 multiplied by pi. Okay. And this will be cos of 2n plus 2 pi. Okay. So now this gives minus 1 and this gives 1, so it will be minus 1, 2. Okay. So value of this is 2. Okay, so obviously, okay, first let me show you guys that, like how I am evaluating this, like cos 2n plus 1 into pi plus cos 2n plus 2 into pi. So first we're gonna take the graph of cos x, which is like is actually sin x. Hey, sorry for the interruption. If you are finding this video helpful, make sure to hit the subscribe button and turn on notifications so you don't miss out on the future videos. Your support helps me keep making more useful content for you. Now, let's move on to the next question. This and this will be the graph of cos x. Now, see that it's 0 degree here, it's 90, it's 180, it's 270, 360, it's 450, 540, and this will be 630. Okay. If we take n equals 1, this will give us 2 into 1 plus 1, which is 3 pi. So this will give us 3 pi, okay, which is 540. This will be minus 1. For n equals 2, this will give us 2 multiplied by 2 plus 1. This will be 5 pi. So this will be actually 900 degree, and it will also give us minus 1. Okay. So cos of 900 is minus 1. So this is going to actually give us minus 1. Okay. And for the value of n equals 1, this is going to give us actually 2 into 1 plus 2, which is 4 pi. Okay. So this will be here. So this will be cos 360 is this 1. Okay. For n equals 2, this will be cos 2 into 2, 4 plus 2, 6. This will be cos of 6 pi, which will be again 1. So this is going to give us 1. Okay. So that's why it's minus 1, and it's minus, and this 1. So just like mod of minus 2, and it is 2. Okay. So now we get this equals 2. So limit n tends to infinity will also be 2. Now what we can see that xn minus yn is tending to 0, but functional value of xn and functional value of yn, so this is not tending to 0. From here we can say that cos of 1 by x is not uniformly continuous on 0, 2. Okay. Now the second approach, method 2. So for this one, we are actually going to use a theorem, which is if is uniformly continuous on an interval, let's say it's d, then we can write that for every Cauchy sequence, let's say it's sequence un. So for every Cauchy sequence un in D, if the sequence f of un is also a Cauchy sequence. Okay. This will be in R, actually not in D. Okay. As f will be D to R. Okay. So the codomain set is R here. So un is a Cauchy sequence in D, and f of un will be a Cauchy sequence in R. Okay. Now let us take a sequence, say xn, which is actually 1 by n pi by 2. This will be 2 by n pi. Okay, so we take this sequence which belongs to D, not belongs to, in open 0, 2. Okay. So now this is a Cauchy sequence in open 0 to 2. Now xn is a Cauchy sequence in open 0, 2. Okay, so now we get xn is a Cauchy sequence in 0, 2. So now the condition was f of xn must be a Cauchy sequence in R. Okay. So like if f is uniform continuous on this interval and xn is a Cauchy sequence in 0, 2, like this interval, then fxn must be a Cauchy sequence in R. Okay. Xn is equals 2 by n pi. So again I forgot to mention that n belongs to set of natural numbers. Okay, this is actually very important. I forgot to mention that. I forgot to actually mention this. Now we're gonna evaluate that the first value of f of xn. Okay, so for n equals to 1, so for n equals to 1, what do we get? It will be f of 2 into 1 by pi. This will be f of 2 pi. Okay, which will be cos pi by 2, which will be 0. So the first value will be 0. Okay. Now we're gonna evaluate the second value. For this should be x2, which will be 2 by 2 into pi. So this will be if of pi. No, actually, this will be if of 1 by pi. Okay, and this will be cos of pi, which is minus 1. Okay, so minus 1. So now if we keep calculating these values, this will be 0, 1, 0, minus 1, so on. So as we have seen that sequence f of xn has this kind of points. Okay, like 0, minus 1, 0, 1, 0, minus 1. So from here we can say that if the sequence f of xn is a divergent sequence. Okay, why? As like it cannot converge to a single point. Okay, so now by the theorem I have shown before, we can write that what do we get? Okay, we get this sequence xn in 0, 2 or sequence xn is actually a Cauchy sequence in 0, 2. Okay, but this sequence f of xn is not a Cauchy sequence in R. Sequence in R. Okay. So from here we can write that f is not uniform continuous uniform continuous on 0,